So today we will be doing something very interesting. Okay, we'll try to give life to static images through AI. When I say static, there will be images. There will be images, and there will be wisdom. That is knowledge, and will give this knowledge to the static image. So the static image will show liveliness. It will show life. That no, it is speaking by itself. So the whole idea is to integrate a lot of semantics. I will just summarize it quickly, okay, and we'll demo that first to just keep you all engaging, because this is one of the very hardest project what I have done recently, and it's like a magical thing for me, because I have seen these things over Gemini and other generative AI bots, but how it used to do, I always wanted to go into depth and try it by myself. So the whole idea is you will give an image, you will give a text and or a document, and the image will start basically talking the language what you have provided, or the text, or the PDF information or knowledge what you have given, as it was live. Okay, just to give a very quick demo, and then I will run the live demo first and go through the architecture, the whole nitty-gritties of the implementation one by one. But just to give you an overview of how the everything is worked, I have some pre-run executables, okay, which I will run on, and will show you how exactly this looks very magical. Okay, so this is I have taken a Bhagwat Gita example. So this is an image downloaded from Google. Okay, this is the JPG image you can see, and this image has a clarity of the mouth, the eyes, and everything. As of now, I have only implemented liveliness around the mouth face. Okay, so this face, this particular part of the image should start rendering the Bhagavad Gita. So I have taken the PDF as few chapters, or you can say some part of Bhagavad Gita, which I will show, and this will start dictating the Bhagavad Gita in itself. So the PDF what I have taken is are these two. Okay, these two are the PDFs which have been taken. You can see there is a Hindi and the normal. So this is the PDF. I have taken few sloks and some conversations from Bhagavad Gita, and for the demo purpose, and similarly I have taken for the Hindi, I have added some Hindi text to the Hindi PDF. You can make it chapter wise. I will show how it is structured. It is a very well structured application in which you can extract chapters, and chapters can be spoken by the avatar you give. So one of the images I show you, that I have for real person, for the real purpose semantics, I have taken Krishna here, and Bhagavad Gita text. So the end goal is to make this to have some life into this particular image. Okay, let's see the demo first, and then we'll go into the semantics slowly. Okay, just for the resolution purpose, I will keep it strong, so you can see here. This is the image what we took, which I just showed you, right? And now the whole idea is to use multiple machine learning models. There have been multiple machine learning models that have been used. One of the primarily used machine learning models is lip syncing. As I said, it works mostly close to the lips and related facial areas, and you will see the effect just now. So I'm just playing this so that you are able to understand what exactly this project is bound to. So this is an English version. Okay, so ideally this static picture what I give should be lively as per what the not the semantics of the project is.
Chapter 1 Dhartarashtra said, O Sanjay,
So
after
you can
my
see
sons and the sons of Pandu assembled in the place of pilgrimage at Kuruksetra, desiring to fight, what did they do? Sanjay said, O king, after looking over the
so you can clearly see, right? It looks like no, this image has been given the power or the life. It was a static image, and suddenly no, with some with some machine learning, it has started no speaking, or started to feel like it has life. Similarly, I have used a Hindi version for it. okay, and that reads out the Hindi in natural language, and tries to speak whatever it has into the Hindi text.
भगवत गीता डेमो अध्याय 1:1 धृतराष्ट्र बोले, हे संजय, धर्मभूमि कुरुक्षेत्र में एकत्रित युद्ध की इच्छा वाले मेरे और पांडु के पुत्रों ने क्या किया? संजय बोले, उस समय राजा दुर्योधन ने व्यूहरचनायुक्त पांडवों की सेना को देखकर और द्रोणाचार्य के पास जाकर यह
You can see, right, how amazing this is, and it is just a start, right? I have given life to only this part of the face. You can add facial movements, you can add like something like eye blinking. A lot of motion can be added across the picture. The whole idea is to demo how exactly these very advanced so-called very advanced generative AI concepts work in inside, okay, and how exactly they are coded, basically the whole architecture, how the whole architecture is. So having demoed this, now let's try to no actually run the demo live, okay, first. And in the meanwhile, when it runs, I will try to, so this is the output folder, this is blank as of now. My project is expected to create this these two multimodal outputs inside this output folder. So once I run this project, I'm expecting my two mp4s to be generated inside this PDF. And just to make sure that it's not hard coded, right, I will just try to show you one another case where I have used another picture. So this is another picture here. Again, this is a different Krishna, right, from what you saw. And let's see the same text spoken by this Krishna, okay, and you will see the similar semantics or meanings.
Chapter 1 Dhartarashtra said, O Sanjay, after my sons and the sons of Pandu assembled in the place of pilgrimage at Kurukshetra, desiring to fight, what did they do? Sanjay said, O king, after looking over the army arranged in military formation by the sons of Pandu, king.
Okay, similarly the Hindi one, right? Let's play for a few seconds how this goes, and then we'll start looking into the architecture and the code.
भगवत गीता डेमो अध्याय 1:1 धृतराष्ट्र बोले, हे संजय, धर्मभूमि कुरुक्षेत्र में एकत्रित युद्ध की इच्छा वाले मेरे और पांडु के पुत्रों ने क्या किया? संजय बोले, उस समय राजा दुर्योधन ने व्यूहरचनायुक्त पांडवों की सेना को देखकर और द्रोणाचार्य के पास जाकर यह वचन.
Okay, so this is the actual output what we have got from this project. And as I said, I will run this project live. In the meanwhile, we'll start understanding the semantics, the different architectures, the code base, okay, how it has been structured, and then we can have the final go at it, right? I will run the demo.sh here just to make sure that we generate the assets. Okay, it runs in the background and it will create the two different mp4s in Hindi and in English. In the meanwhile, some background, okay, I will just go through how this all works in the back of it. So we know that we are trying to do multiple things here, and it's not very trivial, right? What we have done is we have taken Bhagwat Gita, a static image of Lord Krishna here, but you can take anything. You are free to choose any avatar you want, and you can take any PDF you want. The whole idea is to attach the audio spectrogram that gets generated and to the image, and add the motion to the face. Here the lip sync has been implemented, but a lot of other facial activities can be performed using some of the models which I will mention just now. Okay, so what is the architecture? So as I said, it uses natural language processing, audio synthesis, computer vision, and GAN. Okay, so basically how this works is the first step is neural NLP and audio synthesis that uses transformer internally. Okay, so it goes beyond the OCR, and it basically what it does, it basically tries to no take the visual representation from the image, map it to the audio step by step, and there is a GAN which we have used, like here for example I have used a wave to lip. Wave to lip is a paper, and that paper talks about, so this is the paper, wave to lip paper. Okay, this was published I think in 2020, yeah. And this talks about lip sync. Okay, so given an image and an audio, what it does is it will use a GAN structure. Okay, I will just explain the architecture. So this is the GAN structure. So this is the audio here. You can, in the above red part, you can see the audio that has been chunked into multiple parts, that gets chunked into multiple parts, so that it can attach to a specific time slot of the video. And then it has a trained generator that is basically trained on the lower part of the face being masked. Okay, so it knows how to perform these facial expressions when you speak something word by word. Okay, and once you are providing the actual image, it tries to leverage the same learning onto that image through the L1 reconstruction loss. And then there is a generator which then there is a discriminator which actually discriminates between what has been generated. And we know that this loop of generator and discriminator in the GAN gets on refining and works on the principle of no punishing the generator if it is not close to what it is expecting, using the binary cross entropy loss, and so forth and so on. So the whole loop goes on until a very refined facial expression related to the mouth here, because we are talking about lip sync. And unless that gets generated, it keeps on performing that loop and generates it frame by frame. Okay, so this is what I have tried to use this paper. You basically the whole code of and the model of what is it is getting used is already available for free. You can implement it, and it's as I said, it is one of the major and core applications, or one of the core things what has been used in this algorithm, or the whole end-to-end algorithm of this particular in infusing life into wisdom project. So as I said, the generator takes a static face and the audios, right? Reconstruct the mouth region frame by frame, aligns visual phonemes with the spoken audio. And the job of the discriminator is basically, as I explained, it is a pre-trained lip sync expert. It penalizes even micro level desynchronization happens, and by recognizing a face and the precise bounding box of the lip and the area where the speaking part is most impacted, it applies that audio and the visual at that point in time, and it no feels like the lip sync is happening, and it has brought the image to life. Okay, as I said, the outcome is language agnostic, end-to-end multimodal pipeline. It has been done for Hindi and English. I have used example here as Bhagwat Gita and Krishna here, but you are free to use any avatar and any text, and it will work just fine. Okay. As I said, this is one of the very complex projects, one of the most complex projects what I have built recently. And let's go through the architecture one by one. First, let's see if the outputs are generated. So we ran this. I think it has ran for us, and we'll just validate that the pipeline has successfully executed. We'll go through live from AI project, and you can see the output is generated from the pipeline, and it is same as what we ran in the start of
Chapter 1 Dhartarashtra said, O
the video.
Sanjay, after my sons and the sons of Pandu assembled in the place of pilgrimage at Kuruksetra, desiring to fight.
Okay, and we'll just test the Hindi one as well.
Bhagwat Gita demo Adhyay 1.
So this is the Hindi modal version.
संजय धर्मभूमि कुरुक्षेत्र में एकत्रित
Right.
युद्ध की इच्छा.
Now let's look into in a bit depth. Okay, I will just go through the code with the interest of time. Will snap through one very quickly. So first of all, let's try to look into the architecture. Okay, I have created a very clear project report.md. I will be uploading the whole GitLab project for this whole thing into the GitLab, so you can see and go through the project report. But let's go through it very quickly. As I explained, the system it takes the input PDF extractor, and then it takes the audio, right, the audio file, and it takes the model that is the GAN, right, the GAN model, and it tries to fuse both the audio and the audio generated from the text. So first of all, the text has been converted to an audio using a model, and then that audio has been infused with the image, whatever is whatever has been provided to it as an avatar. So you need to basically provide this in some specific order. I'll just see if I have a architecture here. So there is a readme as well, right? Let's go through the readme. So I think it should be in the project report. Okay, so it will come. It is in the down of this particular page, but I will just first of all walk through. So the tech stack used here, as I said, it uses Python 3.0 ffmpeg for no audio video processing, right? It has the codecs for audio and videos, and it merges both of them semantically. For that I have used ffmpeg. Libraries and modules: PDF plumber for extracting the text from the PDF, processing it, cleaning it out. And then text to speech, I have used Microsoft Edge TTS model here, that actually converts the text that is there into the specific language. You can use multiple languages. As I said, it has support to multiple language. I have demoed here for Hindi and English. And then, as I explained, it uses a paper called wave to lip, basically used for syncing of lips or bringing in expressions when you speak, using the GAN or generative adversarial networks. Okay. A quick overview of the AI and machine learning part. As I said, the first important thing is the generator discriminator model. As I said, how it does the lip syncing is in the paper, but overall it marks the lower part of the face, and it uses its knowledge base. A pre-trained lip sync expert is there in the discriminator that is able to give feedback to the generator, and at the end of it, given your image, it is able to produce as good as real-time no effects on the given image. For audio processing, I have used MEL spectrograms here. It uses the encodecs used inside the audio, and it just maps the text into the audio, transforms, and finally creates that MP3 so that it can be merged with the videos that gets created out of the GAN model visual, right? We definitely use a face detection model here known as S3FD. Okay, and that model is responsible for detecting the face, parts of the face where GAN needs to be applied, right? And that it's again one of the machine learning models that is getting used to do some work. Then, as I said, there is a TTS architecture, text to speech architecture. Here we have tried to use Microsoft's Edge TTS, which does all of the work. It's not like we are not going into the depth of the audio processing as of now. The more important semantics is using GAN, how the lip syncing works, right? The lip syncing works, and how all of these gets merged to create the liveliness effect into the video. Okay. So here you will find the step-by-step demo of the whole code. I have tried to document what each part of the code does, right? So it's basically start from main.py or demo.sh. So here is the demo.sh, and inside this demo.sh you start checking, first of all, checking for the different libraries and the different installables that is required to run this project, and finally it calls python main.py with particularly whatever you want. So I have passed in Hindi, and then passed in the English version of the PDF, and then you have to pass in the language in codec here, and then it you have to specify where your output needs to be generated. Here I think the outputs, as we mentioned, the output has been generated inside this output English and MP4 here, right? So this is the first path where everything begins, and then similarly you will find the whole documentation around this project inside this detailed workflow and execution logic, right? There is a detailed architecture which I have developed. Here I will just try to open it and show you step by step. That will make a lot of things clear here. It's a very big project. If I start coding it from the scratch, actually it will take almost a day, right? And it doesn't make sense. Everything is available to your to you on GitHub. You can just try it. I think you will find it pretty interesting. So I will just try to open in associated application. Let's see if it opens. Yeah. So I hope this is visible to you, but still I will do some bit of um, zooming in. Okay, let's start from here, right? With respect to this particular project, this is the whole architecture of the project. Let's zoom into the different components, and it will all start making sense, right? So this is the user. You have a PDF that is the knowledge base, right? And you are allowed to give in the input layer the PDF document, the image, the static avatar, and there is a master script which I shown you, main.py or demo.sh, that basically takes in, and you have to know select the, as I explained just now, when you run it you have to pass in the language encoders, and you have to select a specific language there, and then there will be a PDF extraction that goes on, right? That PDF, from PDF the text are extracted and it is passed to the audio module, right? And after passing into the audio module, so you can see this particular line, right? First of all, this is connected to this, right? Audio synthesis module. It has the all the audio synthesis steps here. So it breaks the whole audio into spectrograms of smaller chunks, so that the whole video doesn't get impacted once it is chunked or mapped with the small part of the small part of the video. And then once this audio is generated, right, after the spectrograms are actually taken out, the and the video part is getting dynamic video input that gets generated for the final deep learning inference. The both are basically given on to this particular module, which is the deep learning inference module. And when you actually run the wave to lip GAN generator, wave to lip GAN module on these two parts, it tries to synthesize and generates the combination of the combined video and audio, which is your final MP4 generates as part of this. So it looks complex, but no, it's very easy to follow through, and as I said, it has a lot of value, because I can start correlating with all of what ChatGPT or Gemini does, after taking the no different modules of this particular course. So now coming back to the project structure, as I explained you, there's an asset, right? Outputs. There is a source, and it has a set of 4 files. There is a central configuration. Text extraction logic is all inside PDF extractor. TTS generator, video generator is responsible for as a wrapper of wave to lip. And this is the model here, right? You can see here wave to lip folder, the AI model submodule. It has it we have checked out the model on the local, and we are using the checkpoints to do the inference. And this is the demo.sh which I was talking about. Challenges and solutions, as I said, a lot can be done. I have only tried to integrate a few lively parts like speaking from the mouth, like the syncing of lips here. But as I said, a lot can be achieved, adding motion to the face and all that, right? This code is very simple. Okay, let's go through it quickly. This is the config file, right? That contains all the configs, and it is responsible to generate and ensure that all the folders and the different artifacts are placed at the right place. PDF extractor, as I said, it has multiple methods. Let's go through them quickly. One is extract text from PDF, and then which is responsible to extract the text from the PDF. Then read PDF content. Okay, it will clean some of these some of the things, like you can see here, if something like this is happening, like it is in the new line, right? Exam and new line, we have ple, then it is basically cleaning that and making that to a single word, so that the model, when it actually attaches the audio, it basically gives you the feel of a single word. Okay. There is an option to extract chapter, like if you have a multi-chapter book, you should be able to extract chapter by chapter and run it on each of the chapters, and see and let your avatar speak the chapter related semantics. The image what you want to, or the avatar what you want to place it, is has been placed here inside the assets folder. Okay, so you will see your avatar, static avatar placed here, and it takes this avatar as it is, and it applies the GAN over this particular avatar to know the bring back in the life. As I said, this is the folder where the model is placed in, and this is the path to the model. All the parameters and the weights related to the model has been placed here, so that when you do the inference, it actually uses this path and the folder to actually predict and apply the model related semantics what is needed. Okay, and all of this has been clearly and very in an organized way have been mentioned inside the readme file as well, right? The project is called life from AI. Okay, it is trying to give life from AI, and I hope this brings you an intuition how powerful AI can be, right? And basically it can do a lot more when it is combined with multimodalities like audio, video, and whatnot. As I said, the code is very simple. I went through most of it. This is the audio related file, this which generates the audio chunks. As I said, the multiple chunks are getting generated, and it combines the audio. It generates the final audio, and finally we have some utility files that actually sets up the logger and all, and then this is the final video generator that actually generates the avatar video, calling all these things and placing everything into one go. So just to recap, multiple things I have gone through. The main important aspect would be to go through the project report. Okay, this will give you a good insight of what has been done step by step. And this is the architecture diagram.png, which you can open in any image viewer, which I think I opened through the normal Mac preview, and you will be able to just correlate how things are and the data is flowing end to end. So yeah, I think this should give you goosebumps. At least it gave it to me, right? Initially I used to see these getting generated from the console or the chatbot applications, but I am able to do it on my machine. I am able to code that from the scratch using my local machine. And yeah, it is wonderful exploring the world of AI, and all this. Do go through this paper. This paper is an awesome paper, which talks about the wave to lip. It is called wave to lip library basically, and it is basically the no, you can say, the main helping tool that has let me develop this application. Okay, I hope you find this very interesting. Okay, and yeah, I will be glad to listen on your feedback and how you find this, and happy to connect again. Thank you very much.